Alright, this is part 4 of a lesson on factoring polynomials and finding all their zeros, even when we're dealing with degree 4 or maybe even higher. But the first thing I like to do is put the function into my calculator to see if I can find any zeros hiding around there. You know what, I am going to look in that calculator, but I'm noticing a pattern. I'm noticing grouping could work. You see that it's 4 terms, so anytime I'm dealing with 4 terms, I sort of look at it and ask myself, could grouping happen here? And just as I was getting this ready to switch over to the calculator, I'm looking at it and I'm thinking, what's the GCF of this pair? And they're both divisible by 9. You know what I mean? If I pulled out that 9, okay, which would really mean dividing by 9. You know what I'm talking about. Okay, divide by 9, divide by 9. Then that's going to give me, really negative 9. That's going to give me 2x minus 3. 2x minus 3. And I'm seeing the 2 and the minus 3. And I can see if I pulled out x squared, this would also be 2x minus 3. So grouping is really what we should be doing. Okay, so I'm going to go ahead and do grouping. I'm curious what would have happened in the calculator. So let's just take a look and see what happens if we go straight to the calculator. So here I've typed it into my TI-30 using the table feature. I like to start at negative 10 because the zeros rarely go past that. And I'm going to scroll down looking for zeros on the y side and see what happens. Okay, I do find a 0 right here. So if I wanted to, I could go ahead and use synthetic division and such. But just understand we could use grouping on this, and I'm just going to do the grouping real fast. X squared is the GCF, so I could have brought that out, and that would leave behind 2x minus 3. Okay, negative 9 is the GCF like I just showed you, and that would leave behind 2x minus 3 again. If I factor out the common 2x minus 3, that's going to leave behind x squared minus 9. And then x squared minus 9 is further factorable as x plus 3 times x minus 3. Okay, so I really didn't need synthetic or a calculator, and there I factored this completely. And then as far as the zeros, I'm going to get 3 over 2 from this, and I'm going to get negative 3 and positive 3 from those. So that's really the quickest way to do it if you're comfortable with grouping. Now I'm betting that most of you didn't notice the grouping, so I'm going to go back and show what you would have seen. So if you use the negative 3, not realizing about the grouping, okay, then you would do like this: 2, negative 3, negative 18, 27. Okay, so I've got the negative 6, that's negative 9, that's 27, and that's going to be positive 9, and that's negative 27, and that's 0. Okay, now I could go ahead and factor this. Well, I guess let me write it down first. So I've got 2x squared minus 9x plus 9 so far. Alright, and I could bring down the factor from the negative 3 would give us x plus 3. So here's what we have so far. Of course I will keep the x plus 3 hanging around, but I would try to factor this further. So 2x squared will only factor as 2x and x. 9 is probably 3 times 3. If this doesn't work out, I'll try 9 and 1. Okay, but it's all about the inner plus the outer has to give me the middle. Inner, I've got 3x. Outer, I have 6x. I'm trying to get a middle of -9. I can get that if both of these are negative. So that would make both of these negative, and a negative times a negative is positive, so it works out well. Okay, so here I have factored completely. Alright, I'm just setting this equal to 0 because it's an equation. But I'm going to cut and paste this. We'll copy and paste. Alright, so this is now completely factored. And of course we have our roots of -3. And you know, if I set 2x minus 3 equal to 0 and solve, it gives me 2x equals 3. Okay, so I get 3 over 2 from this. And obviously I'm going to get x equals 3 from this if I set that equal to 0. So these are my factors and these are my 3 roots. Okay. Alright, let's go ahead and take a look at number 8. This has too many terms for grouping. So let's go to the calculator, type this thing in. Okay, I like to start at -10 because it rarely goes past that with those zeros. And I just like to scroll down looking at the y side, and I found my first 0 at -4. So let's go ahead and rock that. Let's see, 1, -2, -21, 32, and 80. Let's see, multiply, get -4. That's -6. It's positive 24. That's 3. It's -12. That's 20. That's -80. That's 0. I'm looking. Will grouping work? Nah, there is no GCF between 3 and 20. So grouping is not going to work. So in that case, I need to find another 0 off the calculator to do this. So let's go back to the calculator, scroll down some more, and hopefully find another 0. Okay, there's another 0 at 4. Okay, so let's do that. So the 0 at 4, okay, I'm just going to put it next to these coefficients and continue the problem. So 1 times 4 is 4. That makes -2. Multiply, that's -8. That makes -5. Multiply and I get -20. Okay, now I'm down to just 3 numbers, a trinomial. This should be factorable. So I'm looking at x squared minus 2x minus 5. You know what? I don't know why I said this should be factorable. There's certainly no reason to expect that it's going to be factorable. Maybe it is, maybe it isn't. But if it's not, that's okay. We will just use the quadratic formula. Now this 0 of 4 would come from a factor of x minus 4. And this 0 of -4 would come from a factor of x plus 4. 5 times 1 is the only way to do this. And, you know, if I try to, this is going to be unfactorable, is what I'm saying. X times x, 5 times 1. You know, inner 5, outer 1. There's no way to get 2 out of that. -2. So this is unfactorable. So first of all, this is now completely factored. I'm going to put it in the answer box. Okay, and of course the x plus 4 came from a 0 of negative 4. The x minus 4 came from a 0 of positive 4. Alright, we're going to get 2 more zeros out of this purple stuff, but I'm going to have to use the quadratic formula. So the quadratic formula says, if I've got something like x squared minus 2x minus 5 equals 0, which I do, I can find the solutions x using the formula x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to be doing this. I like to find the discriminant first though. Okay, so for that reason, I'm going to do the b squared minus 4ac. Let's see, I'll do it. I'll just keep doing it like I'm doing it. Okay, so b squared minus 4ac is called the discriminant. Let's see, so look, what's a, b, and c? A is 1, b is negative 2, and c is negative 5. Okay, a, b, and c. So b squared, that's negative 2 squared. And you should put that in parentheses, my friend. Okay, negative 2 squared minus 4ac. Okay, now I'm very comfortable doing this in my head, and most of you should be able to do it by hand at least. But many of you make too many mistakes, and calculator is for you. Okay, in the calculator, this would look like this. You must put this, if you're going to use the calculator at all, you've got to put this negative 2 in parentheses when you square it. Otherwise, you will get the wrong answer. But I'm getting 24 for my discriminant. 24. Okay, and so remember, that 24, that goes under the radical here. So when I do my quadratic formula, alright, gotta make sure I have enough room. Alright, so the quadratic formula, I'm talking about this opposite of b plus or minus square root. So b is negative 2, so the opposite of b is going to be positive 2. Alright, and then we've got plus or minus square root, but under the square root is b squared minus 4ac. We just found that that was 24. All over 2a. Well, that's 2 times 1, so that's just 2. Alright, so this is what we have to evaluate. Square root of 24. I would go ahead and put that in my calculator. I mean, you know, if you don't know how to do it by hand, which I do, but anyway. I'm not trying to reteach the lesson on simplifying radicals like every time, so we're just going to use the calculator in this demo. Square root of 24 is 2 radical 6, so that gives me 2 plus or minus 2 radical 6 over 2. Now, do you notice that all three of these numbers are divisible by the same thing? Whenever that happens, I like to put a heart around those three things. I love it. Okay, that's why I put a heart around it. Now really, this is to remind me that I can't just reduce 2 of these at a time. You know, if this 2 was like 3 radical 6, I couldn't cancel out these 2's or anything like that. You have to do all 3 divisible by something or nothing. It's all or nothing. And they are all divisible by 2. So let's just go ahead and do that. Okay, let's divide all 3 of these by 2. And of course, that's going to turn them all into 1s. Okay, so that would give us 1 plus or minus 1 radical 6 over 1. Alright, now 2 of these 3 1s we don't need anymore. Okay, this 1 down here, we don't need a 1 in the denominator, and this 1 in front of the radical 6 we don't need either. So this is really it, 1 plus or minus root 6. Okay, and go ahead and please let's look at that as 2 zeros by doing 1 plus radical 6 and 1 minus radical 6. Okay, might have been fun to complete the square also. Maybe next time I'll do it by completing the square. Alright, I changed my mind. Super fast, I'm going to solve this by completing the square. Alright, really fast though. So first of all, I would add 5 to both sides. So that's going to leave me with x squared minus 2x, leave a space, is equal to 5. Now I complete the square by doing half the middle squared. Half of 2 is 1, 1 squared is 1. You have to add it to both sides of the equation. Okay, this is going to factor as x minus 1 times x minus 1. Okay, but the whole point is to write this as x minus 1 squared, so I'll do that, and that's equal to 6. I can unsquare this by taking the square root of both sides. Alright, gotta be sure to remember to put a plus or minus on it. Okay, whoops. So that's going to leave me with x minus 1 is equal to plus or minus radical 6. Then I need to add 1 to both sides, and we'll put it in the front. So that gives us the final answer of x equals 1 plus or minus root 6. Now, completing the square is probably only a good option when the middle term is even, and it helps to have a leading coefficient of 1. So I probably would prefer to solve this by completing the square because I'm very comfortable with it, and I can do it a little bit faster than the quadratic formula. Okay, now that's the end of this video. There's one more video left. Probably I'll be the only one who ever watches it. We'll see.